Last time, we were looking at a prediction model. We were looking at how insurance charges depend upon things such as candidates' age, BMI, sex, children, smoker, and so forth. And the original prediction worked of this set, where we found that age seemed to matter, sex seemed to matter, but actually didn't. It was statistically insignificant. So when we're predicting it, we can't have anything that's statistically insignificant. Which means that quick recaps, smokers seem to matter. So over the lifetime, they would end up paying $23,823 more for health insurance, and followed by children, followed by BMI, followed by age, and then sex was not significant, which basically means we've got to, in order to predict, we need to rerun the prediction with the basics said that if any of the predictors x's are not significant, you have to run the model again with only the significant x's. So for the sake of brevity, what I've done is I've reset the model again, taken out sex, and now you see we're saying insurance charges, because sex has been found to be insignificant in determining insurance charges. I'm afraid we had to take sex out. So we've got age, BMI, children, and status as a smoker as the four x's that define the y, which is insurance charges. So what we did was, once we've created that, we go back to running the regression model again, and we say that, all right, regression, but this time we say, all right, y is e, so once again E1 to E1339, x is A to D, given that now we don't have sex any longer, A to D. First row labels, still a 95% confidence, and we set out our output as G right out there, and then we click on OK. And it says, well, you're going to override the existing data because I already run it. I'm going to say OK, and it should give you a quick run once again. Now, once we get the quick run, it now gives you a chance to take a quick look at what exactly happened. So let's look at the adjusted R-square. Remember we talked about it, and that's important to look at. If you go back to your old prediction model, you'll see that the adjusted R-square, including sex as a variable or as an x, was 74.87%, or 74.88 actually. But now that we've run it again, it says 74.89. It's actually gone up, which basically means that sex was not only not explaining the variation in insurance charges, but it seemed to be dampening the data set a bit, so our R-square has actually gone up. So that one's very important. Going back to it, and all right, let's use this one to mark it. Next, of course, we go into checking if it's significant or not. So once again, we'll do the same bit in terms of converting into it into a significant or not. If the p-value is less than 0.05, then let's call it significant, else we'll call it not significant. And now we just need to make sure that they're within inverted commas, because they're text, or else it won't understand what we want. And then click enter and say significant. If we were to run through all the four variables, well, the first one really doesn't matter, the intercept in this case, because we'll talk about that in a tiny bit. So now you see that all are significant, which allows us to now build a prediction model. So let's start building a prediction model. So in a prediction model, the setup for that is Y, which is nothing but insurance charge, is a function of, or depends upon, the intercept plus age times the coefficient of age. So I'm going to just copy that so that we'll be using the term coefficient of many a time, plus BMI times, of course, the coefficient of BMI, plus next is children, right, let's say, once again it's Y, insurance charges. I just made a quick mistake and that I have to redo the typing. Intercept plus, once again, age times coefficient of age plus BMI times coefficient of BMI plus smoker, which is yes or no, times coefficient of smoker. All right, let's say turn that into a yes with the proper formatting, plus the final one, which is let's say plus children times coefficient of children plus smoker times coefficient of smoker. So once again, let's do a quick run through. Y, which is insurance charges, will depend on X's, but you have to bring the intercept in for the prediction model. And we're only bringing in the X's that are significant, or the predictors that are significant, which were age, BMI, children, and smoker. And then all you do is multiply each of them with the coefficient of each of their sets, which comes out of this bit in general. So these are the coefficients, I think, last time. So once again, let's mark them the way we marked them previously. I hope I remember the colors. Actually, don't remember the colors very well, but nonetheless, so that was that, and say coefficients marked as that. So we've got all of these things. So it depends. So that's the general structure. Y will depend on intercept plus the variable, or the X, times the coefficient of X, plus the next X times the coefficient of the next X, plus the third X, coefficient of the third X, and then the fourth X times the coefficient of fourth X. Then that allows us to now start plotting, and we want to start doing our predictions. So let's say age is 30, BMI is 25, children 3, and smoker 1. Would we be able to calculate what the likely insurance charge might be? And that will be following the same formula. So it's equal to the intercept plus the coefficient of age times the age plus the coefficient of BMI times BMI plus the coefficient of children times children plus the coefficient of being a smoker times whether you're a smoker or not. And then if we click it, you'll suddenly see that your lifetime insurance premiums or insurance charges are calculated. Now the only thing is, if we change these values, you should get a quick sense. So suppose you say, all right, next person who's coming up is not going to be a smoker, and we say, all right, so that's 0, and you immediately see it's changed to from 28,000 or whatever it was to $5,099. What happens if they have 5 children? You immediately say it's going to be about, we would predict it's likely to be about $6,046. What happens if their BMI has changed from 25 to 30 and they've gotten a bit overweight? And then you say, all right, it moved from being 60-46 to, once you've got 30, to 76-55. What happens if the age is 50? You say, all right, person enrolling with an age of 50 will have $12,812 in terms of insurance. So suddenly, you're being able to calculate that without worrying anything about it. Now, the interesting thing is, this gives you a good sense. So what you're saying is, you have 95% confidence that age, BMI, children, and smokers, whether you're a smoker or not, will explain about 75% of the variance in insurance charges. And each of these coefficients tell you the impact of each of these X's on insurance charges, which you can therefore use to use that formula, which is right out here, to create your own calculation. Now, one thing, oftentimes, if you want to force a cell to be fixed, all you do is you force the cell to be fixed by, if you're on a Windows computer, Windows machine, you just press F4, and that'll just add a dollar mark, and a dollar basically says it's anchored. So in this case, let's just try and anchor it on a Mac. It's function and F4, and the minute I press that, it changes it. So the ones that are anchored would be the ones that are the coefficients, because we don't want the coefficients to keep changing, or if we were to have a large data set. And same thing, F4, 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 and F4. Sorry, must have F4, right. So that way, you really don't have to worry too much about it, and that remains fixed while these numbers go change. I mean, we really didn't need it for this exercise. It's a good idea to have. So now you can predict it. So this is predicted insurance charges over a lifetime, which I think over a lifetime or period or whatever the insurance charges ends up being. So now if you change it and you say, all right, this is a 20-year-old person with a BMI of 25, one child, and is a smoker, this is what you'd expect them to pay in terms of insurance. So that's it. That's a very, very basic set that tells you about insurance. So this is your prediction model with significant X's, or significant X's, and we'll keep it there. And that's your entire set. Thank you very much, guys. And then let's stop it.